Jumpstart Pro Android comes pre-configured with dependency injection support built right out of the gate. There are various different dependency injection libraries that you can use for Android. However, we are using the most common one that is used across the industry at this time, which is Dagger, also powered by Hilt. Now there's two different things we're talking about, and we're talking about Dagger and Hilt. So if we look at the actual documentation, there's actually a site called dagger.dev. Dagger is a dependency injection tool. Now, what Hilt is basically an addition to Dagger. Dagger can get very complicated and very unwieldy very quickly and can get overcomplicated. Hilt sits on top of this to simplify a lot of the process for setting up your dependency injection. So when we say Hilt, what we're actually saying is we're using Hilt to provide all of the Dagger bindings for the dependency injection framework inside of our Android application. Dependency injection is very common inside of Android applications, and getting set up and running is going to provide you a great foundation moving forward as you start to introduce new native screens into your applications, and it sets you up for a good framework moving forward. Let's go ahead and hop in and understand where we have this set up inside of the application. For Hilt to do dependency injection, it needs a couple of things. It needs to know which dependencies it can inject, and it needs to know where it can inject them. And then you have to tell it to inject various things into your classes. So there's numerous ways to do this. The first place that you need to look at is the Jumpstart application. Here we are saying that this is a Hilt Android app. This is an annotation provided by Hilt to let Hilt know this is a Hilt supported Android application. But even before we can get here, we have to set this up. And this is set up inside of the build.gradle file inside of the application. We can see right here towards the top of the file, we are using the Dagger Hilt plugin. At a very high level, this implements Dagger and enables it inside of your application. Now there's many other things that need to happen inside of here, such as setting up our bindings and so forth, which we will talk about. And this is not a full lesson and course on Dagger itself. That is a course unto itself. So once you get into that point, you probably want to dive into Dagger deeper, but this is just a general overview. So it is set up inside of here. And then we can actually tell Dagger this is our application. Now we also need to tell Dagger about any time we need to have any entry points of where things might be injected. This is the main activity, and we're saying, hey Dagger, something can be injected here. An entry point could be a activity, it could be a fragment, it could be a service. So even if we go take a look at, let's say, reset app fragment, we can see here that it is an Android entry point and so forth. Now it's important to note, inside of traditional dependency injection, you usually will follow constructor-based injection, which is usually the recommended approach. However, because of the way that Android is built, you cannot perform constructor injection on Android components such as activities, fragments, services, etc. Those are created and managed by the Android system. Therefore, in these various components that Android creates and manages, you need to do field injection. This is what we're seeing right here in the reset app fragment. In this case, the reset app fragment needs a couple of dependencies to do its job. It needs some app URLs and it needs a user repository. So we provide the inject annotation, which is provided by the JavaX library. And then Dagger will see the inject annotation and say, okay, I know I need to inject the app URLs. Now you may be wondering, where are these set? I don't see these values mutated at all. Where is this set? What Dagger does at compile time is generate code. It will look for the injections. It will find the Android entry points. It will then go find app URLs that are provided in a module, which we'll talk about in a moment. And it will say, I found the app modules. It will generate some code behind the scenes for the reset app fragment and bind everything up for you. So at compile time, you're given the correct version. This also allows you to replace certain values in test environments, which we will talk about as well. So the same thing can be said for the main activity. The main activity also needs various things injected. So it needs a Hotwire initializer and it needs app URLs. So these again are done via field injection. As I did mention, services are also managed by the Android ecosystem. In this case, we have the Jumpstart messaging service, which helps work with Jumpstart notifications. So here we can see we need various different dependencies such as coroutine handlers and dispatchers and user repositories and so forth. These again are injected via code generation at compile time. All right, now let's dive a bit deeper and go look at user repository. User repository is just an interface, but if we look at the implementation, we can see that there is no injections on this implementation. However, we are using constructor injection. Since this is a plain old Kotlin object, we can do constructor injection here, but we need to provide these values so Dagger can say, here are the API services, the shared preferences, the notification repository. Dagger needs to be able to build the user repository implementation if someone requests to inject user repository. So the big question is, where is all of this set up? Does Dagger just magically figure it out? The answer is no. This is where the Dagger modules come into play. All of the dependency injection code for the application that is not the annotations, that is not on top of the activities and fragments, is going to be inside of the DI folder for dependency injection. Inside of this package, also known as folder, you can find all the various modules inside of here. For example, let's just go ahead and open the Jumpstart module. Inside of the Jumpstart module, we have a bunch of different things that are provided. We have the Hotwire initializer. We're saying we need a certain context. In this case, we need an application context. That's going to give us the application object. And then we're going to say we need these various dependencies, and then it will return a Hotwire initializer instance. And we say this is how you create a brand new version of the Hotwire initializer. Then what ends up happening in places such as the, I believe it's main activity, which needs a Hotwire initializer, at compile time, Dagger will look and say, oh, I need a Hotwire initializer. It will then come here and say, oh, I know how to create a Hotwire initializer. There is a provides method. There's a method that's annotated with provides, which means it provides an implementation of Hotwire initializer, and this is how I build it. And then it will automatically generate the code and replace things at build time for you. So in this case, we are able to say, well, there's a context, a dispatchers, repository, app URLs, etc. Now, you may be wondering, okay, where does Dagger know to get the context? In this case, with Hilt, we can use an application context, and it knows how to find that because we're saying, give us the application context, which is just the application object, and the Android and Hilt can find that easily. However, for things like the user repository, dispatchers, app URLs, the notification manager, Dagger and Android doesn't know how to find that. So we have to provide implementations for those as well. So if we go look at app URLs, we can see there's app URLs here, and these need to be provided somewhere. So I'm going to look at the usages here, and then we're going to go find the actual module, which should be inside of main, and it's right here inside of the HTTP module. So we have the HTTP module. Says this is how app URLs is built, and you'll need to return this app URLs implementation. However, app URLs also needs something. It needs a base URL. Where is that base URL created? That base URL is created inside of the base URL module. So we've got multiple modules that are kind of depending upon each other. And this returns just the build configuration value for base URL. Now, if we remember, inside of the build.gradle file, we have various different build types. We've got release, debug, and staging. And depending upon that, a build configuration value will be generated at compile time. So it generates a file that's included in the source, and in that file will be a constant called base URL. It's a string, and this will be its value at release time. And debug time, it will be this value, which is the local loopback address for the emulator. And then in staging, it'll be this URL here. So for our base URL module, we're going to return this here. So you might be wondering, why do we need to return the base URL? Can't we just include that by default? And normally, yes, that would be plenty to do that. However, the power with dependency injection and Dagger in a statically compiled system like this is the ability to replace values and test them in certain hermetic environments. So what we actually have is a test where we can use the base URL and replace it. So let's take a look at the implementation here. We have a unit test, which we'll talk about deeper in the tests. If we look at the unit test here, this is a Android test that runs with Android JUnit, and we'll talk about this in the testing video. But the key point is here with Dagger and Hilt, it has some testing facilities. And what we've done is said, we've told the application when it's in test mode, we want you to uninstall this module. By default, what will happen is Dagger and Hilt will find all of the modules using reflection, finding all these modules. So it'll find the API module, the base URL module, all these ones over here. It'll find all the modules. Then at that point, it will then find all the dependencies and wire them together. It kind of figures out where the build graph, how it gets together. If something's missing, it will error out and let you know, can't find implementation of foo where it's requested at, and then you need to provide that in a module. So in testing though, what we can do is say, hey Hilt, go ahead and uninstall this one. Kind of forget that you found this one, forget about it. And then if we look at base URL module, it only provides one thing. It provides this base URL. Now what we can do in this case is actually in the test say, hey, you know what? I want to bind a particular value for this annotated Dagger thing called base URL, which is a string, but I want to give it a custom value. And it's this localhost 8080 here. And then the power that this gives us is inside of our test, we can use something called mock web server. And this allows us to provide a mock web server that's running in a test environment that's a real like web server you can send requests to. And then I can start it at localhost port 8080. And this will start it at localhost using port 8080. Now, anytime the application is going to make a request inside of its code and it needs a base URL, it will get this URL. Then at test time, when an API is hit, or maybe we need to get the path configuration and testing, which is what we're doing here, it will pull that value down and say, oh, I'm gonna hit localhost 8080, mock web server will respond to that because that's what's running at that port at localhost 8080, and will return the results back that we want. So it allows us to have a lot of testing inside of here. So that is one of the reasons why we use dependency injection. And in this case, we're using these named qualifiers such as base URL, and then we only have one thing inside of this base URL module. A lot of people who look at this will say, well, we can just take all these modules and we can combine them all into one file, call them Jumpstart module, and put everything in there. Would that work? Yes, it would work, and it would probably simplify a lot of things. However, in certain testing environments, you want to be able to uninstall that particular module because maybe it has a couple of things or one thing in there you want to overwrite. And so in that case, we're putting things in different modules that allow us and help facilitate testing in the future. So it sets you up in the future to allow yourself to have a test environment, to do mock web server and all that kind of stuff. So you don't have to hit a real web endpoint. So these are kind of separated into various different modules. Jumpstart module has all of the kind of the common Jumpstart stuff, which is cookie managers and Firebase notification stuff, and everything's kind of assembled here. We've got preferences module where we're going to return some shared preferences. We might need to overwrite that. A repository for the user repository and the notification repositories. Again, maybe you just need to replace the user repository. You could create a user repository module and then you could uninstall that and test and so forth. So this is just a very general practice here of how to set this up. This is the API module, which provides how we're going to communicate with an API. So if I see I need an API service, which is just an interface, I can then say, hey, I can inject it and Retrofit will create it for me. Retrofit is our HTTP library. And then we can then see the API service here. It'll give us this instance and we can communicate with the API endpoint for sign out or add notification token or whatever API endpoint you have. And that's kind of the high level overview of the dependency injection setup on Jumpstart Pro Android. Again, Dagger and Hilt is a very, very deep and complicated topic. This is just meant as a brief overview of how it's set up inside of Jumpstart Pro Android to help you get up and running so you're familiar with some of the concepts. If you need to learn more, there's tons of resources on the web where you can learn about how to use Dagger and Hilt in a more complicated scenario if you need to get there.